Welcome back to the mind-bending world of quantum entanglement. In Part 1, we explored how entangled particles defy space and time. Now let's go even further. In 2017, China's MISIS satellite made history by demonstrating quantum entanglement between a satellite and Earth over a distance of 1,200 kilometers. It proved that entanglement is robust, even across the atmosphere and the vacuum of space. This breakthrough opened the door to a dream once thought impossible, building a global quantum communication network. Instead of radio waves or fiber optics, quantum networks would use entangled particles to send information securely. If anyone tries to intercept the signal, the entanglement would break, instantly revealing the eavesdropper. Unhackable communication, instant detection of spying attempts, a future where information is truly private, but it doesn't stop there. Some scientists dream of using quantum entanglement for deep space communication. Imagine talking to Mars rovers, space stations, or even future starships without the delays of radio waves. It sounds impossible under classical physics, but in the quantum world, what seems impossible often becomes real. Still, major challenges remain. Entanglement is fragile. Maintaining it across interplanetary distances is a monumental task. We'll need quantum repeaters, error correction, and possibly even new physics to make it happen. But every day we inch closer. Quantum entanglement is not just an experiment anymore, it is becoming a tool. A tool that could change communication, computation, and our very relationship with the cosmos. In the end, quantum entanglement reminds us of something profound. The universe is far more connected, far more mysterious, and far more beautiful than we ever dared to imagine. The future is quantum, and it's just getting started.